Evening, sir.
Am I audible, Nitish?
Yes, sir.
Okay, Sankar is also here. We'll wait for 2 more minutes.
Good evening, sir.
Good evening.
Sir, new chapter?
We'll be doing the same chapter. Gravitation part was left. That's why I arranged an extra class so that we can complete it this week itself.
Okay, sir. Okay, sir.
We'll be starting a new chapter from the next week.
Yes, sir.
Who is joining today or not?
Yes, sir. They both will
They
join.
joined the previous. They joined the previous class.
They both will join, sir.
Okay, that's good. We'll wait for 2 more minutes.
Sir, you are currently in college, right, sir?
No, we are having
Or-
vacations.
No, like.
Either.
Okay.
Hi, sir.
Ida.
Hey, Tarun, I'll ask you a question then.
No need.
What?
No need.
Who was the last
Why
person
do
to
you
get
have
a
grudge
champion
with him,
badge?
sir?
What?
I already said
was
you
the
deserve
last-
that.
I hear you. Be quiet, be quiet. Who was the last person to get a champion badge?
What's the last person to get?
A champion badge.
Champion flag.
Bruh, last two class, what were you doing, da?
Shapwa, I'm not into these stupid things that are serious.
Into this, that's what we were doing in class, da.
Hey.
I'm wasting.
Wasting time.
Oh my
I
God.
would have said.
Not wasting time. I'm not coming to these competitions.
No, I just said
God.
who was the last one to.
You just have something on you. Tell who.
You don't know who won?
You're acting kind of sus there.
Do you know who won, Ra? Tarun.
Don't hear you. What?
I'll send it in chat. I'll send it in
Anybody
chat.
message Kongwei?
Sir,
Yes, sir, I'll message him. I'll message him.
yeah, Tarun. I send it in chat. If you say you didn't
Who
get
was
it, I'm
the
gonna
last champion?
come on Monday and punch you in the face.
The champions badge was, I think, with
Don't type that.
Sankal's.
He can hear you. That he can hear you. Do you not type that?
One second.
Oh, last class, sir told whoever gets this correct will get the all those 40 stupid things.
Bro, the
Who got it?
spelling of physics. Oh my
Something,
God.
Who got it?
Oh my God. Nitish,
What is
PHI, da, PHI.
PHI only I wrote, Ra?
Hey, how
Who
was
wrote
the
that
PHI?
Oh, it's PHY. Oh, okay.
Who wrote that physics?
So sorry, sir. It's miss. So the Y
Tarun,
and
you better
this
say it
thing
or
might
else you're acting
switch the
kind of sus.
computer, sir.
there.
That's
Going
the
to
Y.
discuss something
Why is
important.
Y
That's why
and
I want Kongwei to be here. Please message him to be fast.
Tarun, who won?
I forgot who won.
Bruh. I won, Ra.
Oh,
Are you messaging him, Das,
Can you see
uncle?
the screen?
Sir,
you
he's
see
not
the screen?
replying, sir.
Call him,
replying.
Ra.
Okay, then we shall start by now.
Yes, sir. He won.
Sir,
I
I
Okay,
don't
just
have
call him
getting
once.
a chance.
Sir, I can't
just
call
call him
him.
once.
I can't call him. I can only
Okay,
message him. I
okay,
don't
then
have.
leave it.
Call him on
Okay, then leave it.
Discord.
Okay, then leave it.
Let me see.
Yes, sir.
Okay. We'll be starting gravitation today. Gravitation is another topic. Okay. Gravitation. We'll be starting gravitation today. So, what is gravitation? I told you that Newton said something about the
Attraction
gravitational
between
force.
two.
Yeah, exactly. So, any two bodies in the universe attracts any other two
Right.
bodies kept at a certain distance r with a certain force.
of gravitation of attraction.
That is called force of gravitation. Very good. Okay, you all know this.
Yes, sir.
So, we'll start with the
Awesome.
basics.
so
Yes,
one
sir.
second.
Sir,
According to
Kongwell said he'll join, sir.
Okay. No problem. I'll explain it again. According to Newton, the force of attraction as well write this each mass.
Good evening, sir.
Good evening, Violet.
Sir, sorry, sir. I joined a bit late.
Okay, we have just started. Each mass particle of the universe attracts
Every other object.
other mass particles.
The force of attraction. What?
So according to the Newton, the force of attraction
So, like, if
between
I have my computer will attract like someone in America little bit.
Yes,
Yes.
pardon,
it will.
Very little.
Sir, it's
So, like,
yes.
my
Sir,
computer
explained
will
it one
attract
class,
someone
sir.
in America.
Even if you're like 2000
it will.
years, light years
It will.
away, it'll still attract.
Why?
But the thing is,
Why
that
America? Your
too much use that they won't be feeling it.
So like,
your
That's
let's say I
why
have
computer
it's
is
a
also
impossible. Like it's almost impossible to like stop your hand like next to the table, sir. It'll automatically like touch the table, sir.
Do you
Like,
feel the
if you
attraction by
try
a
to-
computer?
Hey,
sir.
Kongwell,
that's addiction.
your
I don't
computer is
feel it,
even
sir.
at Kongwell, your computer is also attracting the is also attracting the nearest black hole there.
So you will be the reason our Earth is gonna get destroyed.
Sir, not
Even your
really,
house,
because every
Yeah,
between every organ.
Everything in this world.
Keep quiet,
Nanda is
everyone.
very recent. Yes, sir. Sir, is it the same for fluids also? Like even water attracts something.
Every
Everything
mass
in the
particle,
universe,
every particle that has got mass will follow this
Oh,
law.
okay, sir.
every single atom will attract someone.
So see here, according
Sir,
to
how do
Newton,
they
Newton
figure
studied
this
the
out,
Black
sir?
particles.
Please listen here, everyone. Please be quiet. Please be quiet. Okay, so what happens here? The Newton studied on this particular law, and he said that every mass particle attracts every other mass particles with certain force. Okay, and while studying the force, he sought that the force is directly proportional. This is a kind of attraction force. Okay, so force is directly proportional to product of masses. Let us say if two
Yes,
masses
sir.
are kept,
Because F
this
is
is
equal
mass
to
M1,
MA.
this is M2, and these two masses are kept at a certain distance r. Let us say. Okay.
Sir, it looks like your network is very clear today, sir. It's smooth.
Can you stop
Why?
saying something useless, sir? So you can continue, sir. So it's directly
Let's say
proportional because F is equal to ma, sir.
Yes. And this
What are
force
you
is inversely
talking, dad?
proportional to square of distance between them. So when we combine these two, we get this F is directly proportional to m1 m2 upon r square. Okay. So if you'll increase the masses, the force will increase. If you increase the distance, the force will decrease. That's how it goes. So when you remove the proportionality sign, you have to put equal to sign and a constant of proportionality. Okay, a constant you have to put. That constant comes with the experimentations. We cannot like directly write it down anything. So G
So,
is
so let's say I am in space.
hmm.
Let's say I am in space, and then there's a huge
First, let me
box.
complete.
Like, yes,
First, let
sir.
me complete this. Then I'll take the doubts. Okay,
Sir,
so
can you explain this again? I don't get it.
that's why I'm asking you to listen here. So
Uh, uh,
force,
uh,
when we keep two masses kept at a certain distance, r, let us say, mass m1 and m2 is there. So this force, Newton experimented on it, and he saw that the force is directly proportional to the product of masses. Okay. Second, what he
Okay.
saw that it is
How,
inversely
sir?
proportional to the square of distance between them.
Yeah, how did he
Okay.
do that, sir? How did he find that?
This
that's
is
Newton's work.
somewhat beyond your syllabus. I cannot explain that to you. Okay,
So
that
without explaining
experimentation
it,
is there
how
in
do?
class 11. That experimentation is there in class 11, but that is beyond your syllabus. Okay, so just remember this: F is directly proportional to the product of masses, and F is inversely proportional to the square
So,
of distance between
so
them. When you
Newton
combine these two,
experimented on something and he proved that force is directly proportional to mass. That's we have to write like that.
like to explain first. When I'm explaining, please be quiet because I need to explain you something else also.
Mute
Now,
also.
when you combine this, you get F is directly proportional to m1 m2 upon r square. Okay, so when you remove this
Yes.
proportionality sign, proportional means what? Like if these are
Like
increasing or decreasing, so respectively, you can get the trend
so
of
this will
force.
also
But
increase.
exactly, if you want to get the exact value, okay, exact value for this particular case, so what you need to get a constant. Like for example, energy, kinetic energy, you must have understood that it is half mv square, right?
Yes, sir.
Yes,
Studied
sir.
it. So you can see the
Yes,
trend
sir.
whether this is m directly proportional to m or directly proportional to the v square by changing the values. But how will you get this half? Half. This is the
Sir,
constant, and this
Ke is
constant
indirectly proportional to MV,
One by
the 1
10.
by
No.
10.
Kinetic
Hey,
energy.
listen
how
here.
is
Now,
it
why
the
are you changing
indirectly
topic?
proportional?
K is
So
kinetic
this
energy,
we
right?
need to get a constant value in order to get the exact value of the force, and that constant value, this Newton got by the experimentation, and he got it as g, and g is said as gravitational constant, whose value was 6.67 into 10 to the power minus 11. This was the value.
That's a
For
Newton
very
meter
small
square
number.
what? Oh, forget
per
it.
kg square. Now you see there. Now you see there. What if? What if I take
The
1 kg mass here?
gravitational constant of which place, sir? Like, is it Earth or is it somewhere else?
This is gravitational constant. Okay. See here. If I take 1 kg mass here, 1 kg mass here, okay, and I keep it at a distance of 1 meter, right? Keep it at a
Yes,
distance of
sir.
1 meter. What will be the force? F will equals to G 1 into 1 upon 1 square. Won't F is equals to G then?
Yes,
Yes.
sir.
Understood? So he calculated the
Yes,
force in
sir.
this case, he got the value of G, and that was 6.67 10 to the power minus 11 Newton meter square per kg square. Got it?
Yes, sir.
You see here, if you keep two
Sir, what
objects,
is the exact value of G, sir? Like, not like 6.67 into
6.67
10 to
into
the
10
power.
to the power of negative 11, ra.
you may go
Like,
beyond that.
not writing like that, like just as a decimal.
2.00, that one, that I don't know. That may be huge. We
What is
studied this only.
the unit for gravitational force?
I've written here. Gravitational,
Actually,
every
meters per
force is
second.
Newton only. Every force is Newton only. Whatever force, magnetic force,
But
electric
you
force,
wrote
gravitational
Newton.
force,
So you wrote Newton
that is gravitational
meters
constant
per
now.
kilogram per.
That is for G. This is the unit for G, not force. This is for this.
That's what I'm saying.
That is
Asking, sir. Gravitational constant.
constant.
What's the
Newton
unit?
meter square per kg square. Newton
Yes,
meter
sir.
square per kg square. You can find it out from here also. See, this is Newton. Newton is to be multiplied by r square, that is meter square, and then you have to divide it by 2 kg, so per kg square. Newton meter square per kg, that is G, right?
Okay, yes, I get it.
Got it?
Yes, sir.
Yes, sir.
Okay. So you were asking now how he
Sure.
got this value as G. So you can keep 1 kg mass, 1 kg masses at a certain distance of 1 meter, and then you'll whatever force you get, you read that, you'll get the value of G.
Yes,
But
sir.
the exact experimentation, there was exact experimentation where he used inclinometer and many other instruments were used. I cannot explain that to you. That will be there in class 11. Right?
Yes, sir.
Yes,
Next
Yes,
thing.
sir.
Next thing. So see here, when we kept 1 kg mass and 1 kg mass at a certain distance of 1 meter, how much force we got? We got the force equal to gravitational constant, and that was 6.67
Gravitational
10 to the
power.
power minus 11, right?
-11. Yes, sir.
Yes, sir.
So you see there, 10 to the power minus 11, so small is the force. Are you getting my
Yes,
point?
Yes,
sir.
yes,
It'll
sir.
be like
So
zero
small
point
is
zero
the
zero
force.
zero 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 zero
Ah,
667.
that much small. So will you be able
It'll
to
be
feel it?
0.11 zeros and then no 10 zeros and then
6, 7.
667.
Exactly. So will you be able to see, feel it?
No,
No,
sir.
No,
sir.
sir.
No, sir.
That is the reason we don't feel it.
Sir, but
Understood?
we'll be able to feel like if it's a, let's say there's a small piece of paper and then like there's International Space Station next to it. So like International Space Station weighs like kilotons. So it'll be able to attract the paper, right?
Sir,
See,
I have a doubt here, sir. I have a
first you
doubt.
write this page and then yeah, go on with your doubt, Sankalp.
Finished.
Sir, but gravity will, like this G, it will be a lot when the masses are also like very big, right, sir? Let's say 10 followed by 20 zeros, that's the mass of an object. And when we multiply that
Where
by
will you
the
get that object?
gravitational,
Where will you get that object?
It's a black hole,
no,
a
sir, it's
neutron
just,
star. A neutron
yes,
star is
sir.
much bigger than that, sir.
So isn't black hole attracting things?
No,
Okay,
no,
No,
sir,
that's
I'm
not
not
take.
talking
Let's
about
not
the
take that example,
gravitation.
sir. Neutron star.
Sir,
Neutron star.
no, it's
Please
wrong.
wait,
Sir,
he's
listen,
trying
sir.
to tell something.
Okay.
Sir, like I'm not telling there is an object like that. I'm telling, let's imagine there's an object which weighs that much, that many kgs. Then
There is.
G will become so big that it will cancel out the -11 zeros and it will have additional 10 zeros following it, right, sir? Then the
That's gravity,
gravitation,
ra.
then it will, sir, like
Please let
G,
me.
the gravitation
I understand your
constant is
point.
equal.
Then there will be some kind of force that will be felt. Yeah, that will be
Yes,
something
sir.
kind of strange because without any contact, two things are attracting each other. But that will be there.
Yes, we can
They
feel that
start
force, right, sir?
denting the fabric of time there. So you'll have
This
so many
page,
planets around.
write this page, everyone. Be fast.
I finished, sir. A neutron
sir,
star is
sir,
much bigger than what Sanskrit said, right,
sir,
sir?
can you
Like
give
a
an
20
example?
zero mass.
Pardon, Tarun.
Sir, can you give examples?
I'm not able to hear you. Come closer to the
Why
mic.
go
Yeah,
why go till a
examples, sir.
neutron star? The sun is heavier than that.
No, what? You said a sun is heavier than a neutron star.
I said
Hey,
our sun is
you know
heavier
how
than
much
10 to the power of -11.
Please
It's
let Tarun speak. He's asking
Okay,
something.
okay.
heavier than 10 to the power of
I
11.
told
It's
whether
heavier than
can you
10.
Okay,
give
shut up
some
now. Okay, okay.
examples?
Once more, please.
I told whether you'll give numericals now.
Numericals.
Sir.
Yeah, there is numerical. Sir. Okay, yeah,
Is
numericals,
he
sir.
asking about
Numericals.
numericals?
Yes, sir.
Yes, sir.
Okay,
Numericals.
we'll do.
Numericals now.
Numericals we'll do at the end. Before before that, we
Sir,
have to
I
complete
have a
the
doubt,
topic.
sir. So in the
Hmm.
question, like if they give like two masses and then the distance, we can still find the force, right, sir? Like they will ask
Wait.
like that also, right? So instead of MA,
Yeah.
Yeah, you have to find the
But
distance.
ours
Then
will
you can
also be given there.
Hey, but then you
written
can't
everyone.
calculate it. It'll be very hard.
Written
yeah,
everyone.
because 6.67. Oh yeah, yeah.
It
You
is
can
You
write
have
tough.
to
G
It
need
is
a,
tough.
something.
even if they give you a calculator, you need full precision calculator.
We will move.
I have a full
We'll move now.
precision calculator.
sir, 1 second, sir. I
Let's
didn't
stop
finish
about
it.
it.
So,
Please
sir.
write it fast because we need to complete more than 2-3
So, like,
topics
it
today.
doesn't show
I
Euler's
actually have
number,
two full precision calculators.
No, like it doesn't show E if you put something so big,
It will show.
Ah, full precision calculator
I
won't
mean,
show that.
like
It'll
what
show the
do I
actual
need to
value.
calculate? Tell. What do I need to calculate? Tell.
I don't know, 50 million into 80 billion.
50 million. Okay.
5
50 million into
followed by 10 zeros and 8 followed by
uh,
20 zeros.
Written, shall we move?
Yes, sir.
I'm just writing that
Pankaj.
equation, sir.
yeah. It says 4 to 10 to the power of 28.
What?
It says 4 into 10 to the power of 28.
I can't see anything from my virtual background, but that's
1
fine.
second, I'll
I can see clearly.
see.
Hey, but it'll show E sometimes, no?
Yeah, that's like that small, like nothing like this and
Yeah,
all won't
if
be
it
there.
should
No.
not show that, then only it's full
It says
precision
4 into
calculator.
10 to the power of 28.
Yeah, if it doesn't show E at any case, it's
Write
full
fast.
precision.
Sir,
One is
sir,
Uncle
have you
Pankaj.
writing,
written
sir.
F
One
equals
is Uncle.
G? Sir, in that below that 1 kg and 1 kg, the distance is 1 meter. Then you have given F equals gravity 1 into 1 divided by 1 square. Then F equals G.
F is equals to G. That is 6.67 10 to the power minus 11 Newton.
Yes, sir. After G, have you written minus?
No, da,
No, this is not minus. This is
correct.
just a
It's
dash
writing that's correct.
name.
Got confused.
So you can go to the next page, sir.
Yes, sir. You can go, sir. You can go.
Written? Everyone, Tarun?
No, right.
Yes, sir.
Okay, we are going to the next page now.
Yes, sir.
Done?
Sir.
Yes, sir.
Yes, sir.
Okay, now see here. If it they'll be asking sometimes to define the gravitational constant. So gravitational constant
Wait, is this in our book, sir? Gravitational
is
constant.
numerically
Is
equal
that?
to gravitational constant is numerically equal to the magnitude of force. Magnitude of force of attraction between the two masses each of 1 kg placed at a separation of at a
1 meter.
separation of 1 meter.
So
Sir,
because
what
it'll
is
just be
the
1, sir. And anything into
sir?
1 is
What's
just
the
the same
word?
number.
Sir, what's the word after 1 kg?
Where placed at a distance of 1 meter.
And also R, sir. Yes, sir. Oh, so this is how Newton found it.
Right?
Very
Now,
smart
what are
he
the
is.
properties
Yes,
of
sir.
it? Properties of attractive this gravitational force.
Yes, sir.
Sir, no matter where the object is or what the object is, only the mass counts.
No.
Keep on
It is
writing.
always. Yes, sir.
R is equal to 2, sir.
Pardon? No, one.
In that,
It's
what
1
did
here.
you write? R is equal to, oh, it's 1 now.
1.
Yes, sir.
Everything, if you put everything 1, then you'll be getting it. Again, this is not working. This is 1 only.
So I got the answer. So,
Got the answer, ah?
Hey,
For what?
not even numerical. Ah.
sorry. Sorry, sorry.
So gravitational force is always attractive. Always attractive. Second, directly proportional to the product of masses. Product of masses. Third, inversely proportional
Indirect to the distance.
to the distance between them.
Displacement. Displacement.
The distance between them.
Displacement.
It follows the inverse square law. You write there. It follows the inverse square law. There are many other forces that follows it. Inverse square
Excuse
law.
me,
That
sir.
means it is inversely proportional to the distance between them. Even magnetic
Excuse
force
me,
is
sir.
inversely proportional to distance between the charges. Sorry, magnetic poles. Even electric force is also inversely proportional to distance between the electric charges. So there are many other forces that are inversely to that. That is called the inverse square law rule. Okay.
What do you mean by
Excuse me,
distance?
sir.
By the way, them.
Between. It is not by the way. Don't use WhatsApp language here.
Sir, what am I supposed to
What did he say?
By the way, he's
Distance
asking
by
like
the way,
in the way
them.
by the way. He's using
Hey.
WhatsApp language here.
Sir, I
Slowly.
have a doubt, sir.
Okay.
Sir,
Slowly
so,
he's using WhatsApp language.
sir,
Yeah.
I have a doubt, sir. Sir, we know that gravitational force and magnetic force are both non-contact forces, right, sir? And so, like, where let's say I place a magnet, and this is an iron blade, and the magnet will attract this iron blade. But if I place a wooden plank between the iron blade and the magnet, it won't attract. But in the case
It
of
will still
gravitational
do.
force, will it still do, sir?
Yeah, it'll just be minute, like
It will.
it'll
It will.
decrease. It will
That
decrease.
force will be
Force
quite
of
less.
attraction.
That force will be quite less. What happens now? Like let us say this is your magnet, okay, and this is your material to be attracted. So there are magnetic rays. You will be studying it. You ask the questions of future classes. So there are magnetic rays, okay, magnetic rays which passes, and that magnetic rays affects the other materials, and that gets polarized and that gets attracted. Do you understand anything like here? What is polarization? What
Like
is
if you take a really powerful
induction?
magnet,
So
we
there are
can
many things that
easily
you need to understand before this concept. Okay, so there are
Sir,
magnetic
I have
rays,
a
and then when you place anything in between instead of air, so what happens that magnetic rays pierces it, but that level depends on the type of material. Okay,
like I have a really strong magnet.
Sir, in which material will the rays won't pass through, sir?
plastic.
I think something like titanium, or I don't know exactly. Exactly, I don't know. I'll have to check that.
Plastic
Okay,
and all
Oh, go
really
through.
just
Okay.
like just like you say, uh, we place a titanium slab in between the iron nail and the magnet, then it won't
Hey,
it can't attract the thing, right, sir?
it will
The
da, there will be
why
less.
would
blade.
someone have such doubts, Ra?
No, my doubt is not completed yet.
I know. Why would someone have
Will
such
it
a
or
doubt?
Okay,
will
sharp.
not
Continue.
attract, sir?
It won't. I mean,
In that case, it won't attract.
can't
Sir,
go
yeah,
through.
yes, sir. But in case of gravitational force, even though that titanium slab is in between the gravitational force and
Lead and
the
tin or
the
mercury are the lead or tin or mercury. Lead basically that is used. Lead is
So there's
basically,
nothing
yes,
that
sir.
can like block
Okay, leave all these
gravitational
things.
rays,
Hey,
right?
Okay.
Earth doesn't
This
sir,
gravitational
create
force is
magnetic
significant.
force to pull us, Ra.
Please listen
Yes,
here.
just like
It's
gravitational force
significant
is
I
there,
between.
does
know
not get
that,
stopped by.
sir. Sir, my doubt was
It cannot
not
be stopped by
completed, sir.
anything,
But
da. It can go through everything.
in gravitational force, the rays go through anything, right, sir? Why is it different for magnetic force, and why is it different? Like, why is
They're
gravitational
different
force and
things. Yeah, they
magnetic
have
force?
their different properties. They don't like follow the same things.
Light won't
They
pass through any
like
opaque object.
magnet has their own magnetic field to get attracted to other materials. There no such magnetic fields are there. You are asking like questions of no use, basically.
What? So
Both are
what have
And
different things.
Sankar.
Two different
Kongwe
things.
was right. Kongwe was right.
I know.
I should have
what
stopped
have you written?
Shankar, but
Is significant
It is
between
significant. Significant.
Significant.
significant.
significant between
Significant
heavenly
between heavenly bodies.
heavenly
Celestial bodies, celestial bodies,
But
Earth, Sun,
or
Moon,
heavenly,
Sun,
whatever, same thing.
asteroids.
stars,
Insignificant
anything. Anything that no, sun is not celestial body.
between ordinary bodies.
Star. So it is also a celestial body.
Yes, it should revolve
Because
around
of
something.
Actually,
low value
what
of
do you
G.
mean by heavenly bodies?
Hey, celestial
Heavenly
bodies,
bodies that are
Earth,
very
Moon,
heavy.
asteroids.
Yeah.
So
Heavenly
what
bodies
about
that are very
Sun?
heavy.
Sun is also a heavenly body, right?
Why sun is attracting the earth in its orbit. That is a kind of gravitational force only.
So is it
Sun is
a
attracting
heavenly
all of the
body?
remaining planets in its orbit.
Sir, I have
That
a
is a kind
small
of
doubt,
gravitational
sir.
force. Yeah.
Sir, let's say I go to space and I see International Space
So useless
Station.
doubts, sir.
No, sir, useless. It's very heavy, sir. It's one of the most heaviest things made by man.
Also one of the most expensive
So
things.
it'll be multiple kilotons heavy. So if I keep a small bit of paper, like 1 meter distance from the space station, will it attract the paper?
It
Like,
should.
will
It
it
should.
attract
Will
like
the
visible amounts, sir?
So
no
you tell me what is the weight of your space station?
Second, sir.
trillion tons? No, it's not trillion tons.
Sir, how is
Billion
Yes.
square tons, sir.
Sir, 420,000 kilograms. That's 420 tons.
20 and ton
Oh,
is
what?
1000.
What?
This was kg,
Sir.
right?
Nice number.
And into what
Yes,
is the
sir.
mass of paper? 1 gram,
Lesser than 1 gram, sir. Okay, 1 gram, sir.
and kept at a certain distance of 1 meter square, right?
Yes, sir. It's 1.
That is to be multiplied by 6.6 into 10 to the power
Divided by
minus 11.
Yes, sir.
So 10 to the power minus 11, 10 to the power 4, and 10 to the power minus 3. So that will be something of the order of 10 to the power minus 9 or minus 8. Do you think that
Sir,
will be
so
it'll
felt?
be
it's still not that significant.
maybe, sir. I don't know if we calculate
10 to
properly.
the power minus 9 newtons.
It's not that
Oh, it's
significant,
10
sir.
to the power minus 9 newtons. Okay, it's definitely
It's not that
feel.
significant, sir.
Write this down quickly.
Bro, that space station is like
So it's
$20 billion.
even the thing which you solved now.
It's the most expensive thing, most
Yeah, it's
biggest
the
thing.
most. That's what I'm saying. $20 billion. Actually, it's not 20 billion. More than that, maybe. I don't know.
You don't know, right? Summa don't tell some random number. Done, sir.
Oh my! Like it's
Everyone,
assumption. What is this?
So should we copy which you
Give me
solved
1
now?
minute.
No need.
1 minute.
Sir, that's big black
Yeah.
screen.
Yeah, I'm just opening. I'm just opening.
It's like okay. 1 second.
Ashwant will buy space station for field trip.
Hey, I was right, Ra. $20 billion only.
Okay, good. You're smart.
Bro, Ambani's house is costlier than that.
What?
Day,
It's not like
not even like
house is $2
$1 million,
billion, Ra.
Ra.
House is 2 billion. It's not 20 billion. It's 2 billion. His house is 2 billion.
And also it's 2 billion rupees,
No, it's
Sir,
no,
this
it's
is
$2
a
billion.
first
dollars.
here.
It's dollars. Yes, sir. Oh wait, what? Sir, we are at the first chapter, sir.
The first slide, sir, ever drew.
Buddies.
Now can you see
2
it?
months back.
Measurement.
Yes,
Yes,
sir.
sir.
Yes,
Go to
sir.
slide 85, sir. 85, 85,
Ah.
85. Is it 85? I don't know. Oh my god, I was right.
Oh my
Written,
God.
everyone. Shall we
84.
move to the next page?
Yes,
Yes, sir.
sir.
Sir, page 80.
Kongwei, turn on a video now.
No, sir.
Once go to the previous. Once go to the
Won't
slide,
even
sir.
be able to
So
see my
how
face.
slow are you, da?
Oh, this slide has gone out.
Yes.
The Tarun has a
No,
doubt,
sir, not that
sir.
one.
Tarun
Not that
has a
one,
doubt.
sir.
sir.
The
I think
84th
they
one.
didn't save.
The 84th one. 84th one.
Okay, see.
How long?
I'm pasting the page here.
Sir,
I'm
this is so
pasting the
slow
notes
at
here.
writing.
No,
Yes,
I
Tarun
was in the
finished, sir.
last word. I was literally in
So
the
can't
last
you
word.
remember one extra word?
I didn't see it.
Can't you see
Sir,
one
you can.
extra
Sir, are you
word?
there?
Nitish, did you finish writing?
Yes.
Yeah, I did.
Yeah, wait a minute.
I did finish
Then
writing
tell it
that.
no. Tell the last line. Because of low value and
It is significant between heavenly bodies, but insignificant between ordinary bodies because of low values of gravitational
Yeah,
constant.
write this down.
Yeah, okay.
So
Sir,
we
you
just
can go to the next
Yes,
one.
sir. Done,
this,
sir.
sir.
Done, sir. Done, sir.
Everyone,
Bruh. The last
Yes,
word was
sir.
G. Da.
because of gravitational.
Oh my god.
I mean, I was gonna write. I was gonna write magnitude of G. Da, simple.
Nitish, what
when
did you tell the
everyone,
last
yes
one?
or no?
G as
Yes,
gravitational
sir.
constant
Sir skipped
or
slide 77.
gravitational,
Very
yeah,
bad.
gravitational constant.
Sir, finish.
Yes.
Yes, sir. Done,
Are
sir.
you done?
Yes, sir.
Okay. Now the next topic.
Shut up, Prashant.
Now see, we have a force between the Earth and every other object also that is present on its surface.
Yes,
Like, let us say this is
Yes,
Nitish,
sir.
this is
sir.
Sankalp. All of them are getting attracted towards the center of the Earth, right?
Yes,
Yes,
sir.
sir. Me and Nitish
Okay.
are very
Yes, sir.
close.
Because they are felt by
Yes,
gravity. And in that case, the force is
Yes.
called gravity.
Yes.
The
Sir, where am
force,
I, sir?
the force,
Hey, you are already gone to the center of the earth.
the
No,
force
da,
with
I'm in
which,
the
Hey,
heaven.
shut up, da.
please listen here when I'm
Yes, sir.
explaining.
Yeah.
The force with which the Earth attracts any object on its surface is called
Gravity.
force of gravity.
Yeah.
Got it? That is called force of gravity.
Yes. Sir.
So now let us say the mass of Earth is capital M and mass of Sankalp is small m. Okay. So in that case, force will be written. Now Sankalp is from the center of the Earth. Sankalp is at the distance of capital R. Now what is capital R? M is mass of Earth.
Distance.
R is radius of Earth.
Oh,
What is the radius of Earth? Anybody?
Okay.
I don't know, sir.
I don't know, sir.
Sir, 20,000, sir.
What?
6,371 kilometers.
Now see here. That force will equals to G
10,000.
M1 M2 upon R square.
6,371.
See here.
Sir,
Agree or not?
6371 radius.
Sir.
Force will be G M1
Capital M
M2
is
upon R
M2.
square. Right?
Yes, sir.
Sir, that's correct.
Yes, sir.
Okay. Now this force is same as that the weight of us, na?
Yes, sir.
Sir, what?
Force will be same as that of weight of us. The weight. This
Oh,
is the weight,
yes,
na?
sir.
Sir, yes, sir. Yes, sir. Yes,
So can I
sir.
write
Yes,
this as
sir. Yes,
mg?
sir. Yes.
Mg
Yes, sir.
G
Yes,
M
sir.
M
Yes,
upon
sir.
R square.
So we can
This
write it as
M gets
kg, right? Because mg is so small.
G will be G M upon R square.
Oh, mass
What
into
is G?
gravity. Okay.
G is acceleration due to
Due to
gravity.
acceleration or
9.8
gravity.
So
meter
when you
per
put
second
these
square.
values, you'll get G as 9.8. When you put capital G as
So,
6.6 into 10 to the power minus 11, mass of
in
Earth as
acceleration,
96 into 10 to the power 24 kgs, and radius of Earth as 6370
371.
kilometers, or
6371, sir.
6.370 into 10 to the power 6 meters, because we have to
6371,
keep
sir.
it in SI unit.
According to Google
Yes,
G.
sir.
You can take 6
acceleration due to gravity and gravity due to acceleration are the same thing, right, sir?
Gravity is a force.
Different.
Okay, so wherever force is there, acceleration will be there, na? Right?
It is the same that you idiot. Uncle. Yes, sir.
Write it down, everyone. If we get time in the end, we'll have some question sessions. Otherwise, we'll have it in the next class.
So I'm
This
waiting
chapter
to take
ends.
that
We still have
badge
20
out of
minutes,
some
sir.
culture.
One line we have connected to them on the diagram, and the other line, what is that, sir? Between Nitish and Sangal.
That's
R.
R.
Is taller,
Radius.
I guess. That's why I made it like that.
Bruh. No,
I
sir.
think
That's
so.
not how it works in real life.
Sir,
I don't know,
actually,
Sir,
in
we
real
didn't even-
life,
Sir, we didn't even add
Sir,
small
actually-
m into the calculation, sir. Small m equals 100.
Yeah, small m will not
you don't
enter the
have to,
calculation.
it's because it cancels away.
Oh yeah.
Why G is a constant. G just depends on the position on Earth where you are standing. If you're standing at the poles, near the poles, G will be quite different.
It'll be
And
stronger.
if you're standing near the equator, the G will be somewhat else.
Less
Sir, weight machine calculates my mass or weight, sir.
mass.
Even if it is machine, it is
Oh.
calculating the mass.
So, but how does that work, sir? Like, if there is no gravity, it will not say I am 39 kilograms, sir.
Hey, Nitish,
They'll
simple,
divide it
like,
with
how it will
9.8,
say that? Yeah, it will divide it by
Oh my god.
Cal
Okay, okay.
proof weight machine is
Okay.
smarter than Nitish.
Oh my god. I didn't think of that.
Done,
So
sir.
everyone say what is
This
that?
Jeez. Yes, sir, and it's higher at poles because the
Sir,
distance.
m is equal to 5.96 into 10 to the power of 24k. Oh, okay,
That's mass of Earth.
Hey.
See that? Earth is itself heavier than that.
What?
What?
What are you even talking about,
Sir,
right?
this is
No,
because of
you
the
said
geoid
neutron.
shape
You
of the
said
Earth.
you said neutron star is like as heavy as 10 to the power of 20 kg, right? I
Did I
said
say
Earth
that?
is itself.
I never said that.
Yes,
Don't
sir.
say it like that.
It's because of
will
the
have
geoid shape of the Earth.
Previous slide for a second.
will have a differentiation between mass and weight. Point number 1.
Mass is constant.
Yes.
Is the measure of
Mass is a fundamental unit. Weight is a derived unit.
Shush, shush, shush.
the measure of
Mass. They
quantity of
Shush.
matter
Shush.
contained in a body at rest. Whereas weight, it is the force.
Applied
It
on
is
the
the
mass
force
due to gravity. Okay, I shouldn't have said that. I'll mute myself.
which Earth attracts the body. Okay.
Yes.
Second point, mass. It is a scalar quantity, whereas this is a vector.
Yes. Sir.
Why? Because it is a force,
Yes, sir.
and all forces are
Because
vector.
of the acceleration, the velocity.
Third
Yes.
point, its SI unit is kg, and its SI unit is
Newton.
So you didn't try to an important point.
Newton or what?
Mass is constant, weight is not.
Yes. Sir.
Mass is constant.
That will be like last but not least.
Sir, mass is a fundamental unit. Weight is a derived unit.
not talking about units.
This is
It is constant for a body
Not constant for a
For a
body.
body,
Body.
it may vary
From
from
place
place to place.
to place
I think we should
or
stop
planet to
talking now.
planet.
Fifth point,
Oh,
it is measured by physical balance.
Mass is
thought you said
measured
good.
by weight
I
machine.
thought you said
So why
good
do we
point
call
for
it
me.
weight
No, the-
machine?
Because
You
that
can
is
call
due
it
to our
mass
self
machine
mass.
also.
So
It is
from now on,
measured
I'll call
by
it mass machine.
spring balance,
It wanna sound like a lunatic.
calibrated.
Wait,
Sir,
sir, I'm
are
now
you
on the
referring
second
us?
point, sir.
Sir,
Sir,
what,
are you
Calibrated.
referring us?
sir, what
To
is the
read
meaning of? Okay, nothing. Sorry.
Newton.
You wanted to know the meaning of calibrated?
No.
Calibrations. Write this down, everyone.
So you muted light when you said what's the meaning of calibrated, sir.
Yes, sir. Sir, that was the first. Let's go.
Do you actually do everything?
Yes.
Why are you still looking down? Focus the liar.
I
Show me the
am
notebook.
a bad liar. Show it with this background on. I said no.
Why remove your background, Rajek? Half the time we can't see you.
For me, it's
Okay, done.
perfect. Like my camera is adjusted to
Put
me.
like some blur. Blur is fine.
As long as my face is there, it'll always show me alone. You're not a dumber computer. What's it, sir, written in the fourth point for weight?
Sir, that.
Done, everyone?
Ah, so what did you write for fourth point weight, sir?
For a body, it may vary from place to place.
Far off.
Sir, you didn't tell the definition of calibrate.
What?
Sir, did you tell the definition of calibrate?
You didn't hear?
What is he saying?
Sir, he said you didn't tell the meaning of calibrated, sir.
Calibrations. Okay, calibrations are marking. Okay, when you see a scale, you see numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 centimeters. So those are calibrations, marking.
Yes, sir.
Almost finished. 1 second, last point. Physical what? It is measured by physical value. Because what
Balance.
is it, sir?
Read it
Google it.
properly.
The
Balance.
balance. I couldn't see.
Which one?
Last year, if you
No,
studied
sir, nothing,
properly,
sir.
you
Nothing,
could have.
sir. Nothing, sir.
Okay.
Our
Yes,
mom was
sir.
an
Finish,
amazing
sir.
teacher. You should have learned everything from her.
Done, everyone?
Wait,
Yes,
sir.
Yes,
sir.
sir.
I guess we won't be able to do questions today. Okay, we'll do it in the next class.
No.
Yes, sir.
Yes, sir.
Hey,
Yes,
Practice
sir.
practice will come.
Nitish,
Yeah. Yeah.
and
How many times you
Konguel,
said?
and
You still have your
Tarun.
badge.
Tarun.
Oh, okay. 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 Wait.
No, look at me. Look
Whenever
at me.
we used to consider
Three.
We can't try.
you
Your video's
remember
off.
the
Yes,
questions of
sir.
free
One.
fall? Do you remember the questions of free fall?
Yes, sir.
Yes, sir.
Play in the class. Do you remember
Sir,
the
this
questions
guy
of
is
free
not
fall?
listening to the class.
What we
Yes,
used to
sir.
take the acceleration there?
Sir,
We used
what did you
gravity,
ask?
sir.
Sir? What did you ask?
9.8 meter per second square.
In free fall,
Free fall question is like when an object is dropped from a place.
is equals to u
Oh,
plus it
that's
will be
9.8.
gt. S will be ut plus half gt square,
GT square.
and
Zero.
v square will
Yes,
be
sir.
u square plus 2as.
2 GS,
Two
sir.
GS.
2 GS. 2 GS. Sir, 2 GS.
Sorry, gs
Yeah.
I'm
or
smart.
2gh you write instead, but s whatever it may be.
Yeah, it's height,
Okay.
no free fall.
So what have you written in FE
So
fall?
what about free throw, sir?
Free fall,
Free fall,
Rade.
Free
Yes,
fall.
free fall.
Hey, my net is so bad, man. No, it's all
We can look at your video and tell.
There's
than my
something called
eyesight.
1 kgf.
What? It's a
kgf.
kilogram
1 kg.
force. It's another
Kilogram
unit for
force.
force.
Kg is like a force value or a unit or unit.
Okay. It is the force due to gravity
No, I kept my pen.
on a mass of 1 kg.
1 kg.
Okay. How can you convert this into Newton? 1 kgf is how many
Sir,
newtons?
9.8
10
newtons, sir.
Newton. 10 Newton.
9.8.
10 Newton.
Oh,
Generally
9.8 Newton.
L.
What is the
Sir,
force on 1
I
kg
was
weight? 1
taking
kg. Force will be 1 into 9.8.
9.8.
Yes, sir.
Understood, Tarun?
MA. Yes, sir. Oh, Tarun.
Yes, sir.
Tarun, bye.
Okay.
The guy with always bad internet.
Similarly, we have 1 gram force.
Oh, the. Okay, you explain.
Oh my god.
Gram. 1
Sir, it'll
gram
be
force is
0.0098 newtons. 0.0098. Correct, no, sir. 0.0098.
it will be 0.0098. Force is 1 gram is 10 to the power minus 3 kg into 9.8. Okay, so it will be 0.0098 newtons. You in units and dimensions I taught you for conversions, right?
Yes, sir.
So you convert 1 Newton into dyne. This is your homework. This is
1
centigram
Newton into
second
dyne,
unit.
no?
This is SI unit.
1 Newton dyne,
Write this
sir. We
down.
already know that.
Sir, 10 raised to minus 7.
No. This is your
Something like
homework.
that,
10
Don't
raised to
look.
5 dynes. Sir, 10 raised to 5 dyne is equal to 1
Sir,
Newton,
what
sir.
is 1 dyne? Like, can you give the definition of 1 dyne, or else we'll just copy from the book because it's already
One
given.
dyne. 1 Newton was what? 1 kg
So 1
with
Newton
1
is
meter per
force.
second square acceleration.
Yes,
Sir,
sir.
sir, we actually already did this, sir.
Yeah, we have discussed it. 1 dyne is 1 gram. Instead of kg, you have to take
Gram per
everything in centigrams.
centimeter.
1 gram
Oh.
and 1 centimeter per second square acceleration.
Sir, 10
It's
raised
like
to
when
negative 5, sir. 10 raised to negative 5.
That is 10
Oops, I
raised to
think
5.
I
5
sir, it's
dynes
in
equals to
CGS
1
system,
Newton.
sir. It's in CGS system. Dyne
10
is
raised
like
to 5 dynes is 1 Newton.
CGS system.
Written
Yes,
everyone or
sir.
not?
I said, yes, sir. 10 raised to negative 5
So,
dyne is equal to 1
Newton,
Newton.
like Newton CGS system is only dyne, right, sir?
What the hell?
Brr.
Force in CGS unit is dyne.
Yeah, that Newton in CGS system is also
Sir,
like
10 to
unit
the
of
power
force.
of 5.
Newton is
10 to
not
the power
CGS
of.
system.
Sir. Sir, 10 to the
Like
power of
Newton in the
5
sense
dyne
of
is equal to 1. Hey, stop it. 10 to the power of 5 dyne
You
is
do
equal
that,
to
no?
1 Newton.
10 to the power 5 dyne is 1 Newton.
Yes, sir.
I just told it, sir.
You said 10
Everyone
to
write
the
this,
power.
and that's all for today. Practice questions. We'll
You
solve
said-
questions, and then we'll get the champions badge
Yes,
in the
sir.
next
Sir,
class.
I'm still
Yes,
the
sir.
defending champion.
He's just gonna go down from the
Yeah.
champion.
You are there. You are there.
Thank
You
you, sir.
Hey, I am the defending
believe that I
champion,
got it,
Debo.
Anna. You still believe that, Anna. You believed it.
Written,
I don't know
everyone?
what were you
Shall we
doing
end
the
the
last
meeting?
Yes, sir. Yes, sir. Thank
time.
you,
You're going
sir.
for excursion.
Everyone
Thank you.
written?
Yes, sir.
Yes, sir.
Yes, sir.
Can you go to the one? Can you go to the 86th slide?
86 slide. This one.
So I'm also leaving, sir. Thank you, sir. Bye, sir.
Right, so one sec. Ah, yes, sir. This one. One sec, sir. Can you go to the last slide? About to finish. Yes, sir. Finished.
Okay,
Thank
done,
you, sir.
Sankalp?
Bye.
Thank you.
Yes, sir.
Okay, bye.
Sir, actually, sir, I have a doubt, sir.
Any doubt?
Like, yes, sir. It's actually not related to this topic, but 1 second, sir. I'll be back. Sir, like, do you have a class right now? Like, is it very urgent?
Yeah.
Okay, sir. Then we can discuss it later, sir.
You can tell me the topic. If it is short, then I can help it with you.
Yes, sir. It is. Sir, it is from wavelengths, and all those stuff, sir. Heat transfer, or
We'll do later now. Those things we'll do later.
no,
If
sir.
I'm
I
not
was just
taught you,
reading.
how can I clear it out? How can I know that what you know or what you don't know? There are different concepts there. Many concepts to be included. Lots of
Yes,
concepts
sir.
are there.
Like, I
And
was
I'll be
just
teaching that,
reading.
then ask them. Okay.
Yes, sir. I was just reading a book, and I was just seeing this, and I learned some stuff. So I just had a doubt. It is on electromagnetic waves, sir. So it's a
You know
very
about
big
electron?
doubt, but we can. So we'll just talk about it later, sir.
Okay, okay. Bye.